I really hate making videos like this. So I bought this amp a few days ago. It was to go straight into service and be used for the upcoming video series with electrostat ear speakers using high power amps, low power amps, trying to find out what's good, what's the best, blah blah blah. So this was like the workhorse. It's a monster thing, and I paid quite a bit of money for it, and it is now dead. It was when I tested it, when I was picking it up, it was working fine, and now it is in protection mode, and it let out the magic smoke. And so just for a little bit of context, I brought it home. I set it up because I was really keen to see what this thing sounds like. I actually hooked up my SRD7 electrostat converter straight away, fired it up, and I noticed it was humming quite loudly. I didn't think much of it at the time because I'd never heard this thing in a quiet environment before. In reflecting on it now, it's obvious that the transformer was under a shitload of load and it was doing damage the whole time I had it plugged in. So it's dead. And I don't know if we can save this or not because most of the stuff in this is not easy to find. So we're going to have a go anyway and see if we can do something with this unit. Now, I've already been looking around doing a bit of the smell test, and it looks like this pair of outputs are either damaged or cooked, or I don't know, but I can see that the resistors are burnt. Don't know if you can see that in the middle there. Yeah, so these are fusible, I think. And it is dead. So we're going to find out what sort of damage has happened and what we can do. Now, this is only ever going to operate in bridge mode. So I have a spare channel, technically. The center channel is not being used on this for what I intend to do with it. So maybe we can use that channel somehow to bring this back to life, because getting parts for this is going to be basically impossible. This sucks. It really does. So let's start poking around and see what we can find. All right. The carnage is not good. So I've desoldered the output transistors and they're shorted and dead. I'll show you those after once I actually get them out. The emitter resistor here is open and gone. This one might be okay, but that's gone, so I'm a little suspect on what is going on here. The carnage here is where everything is going on. We've got 3 burnt resistors so far, and I'm sure something in here is causing that. Probably one of these transistors. I've been looking at the schematic. So the 3 resistors that are burnt up are all on the B+. So they're probably gone. That's probably gone. This whole thing could be gone, basically. And this is not what I signed up for when I bought this amplifier. I don't do SMD work. And yeah, this is just nuts. I don't want to deal with this. We have other channels to compare it to, but the problem is if I take parts from that channel and move it to this channel and I miss something, I'm going to just blow up 2 channels, and there might be something I can do with this center channel as is to get this thing to a state that I can still use it. So let's remove some components and see what we're dealing with. Okay, I think we're getting closer to working out what happened to this amplifier. And this has been driving me crazy because I've been just wondering, like, did I kill this thing by plugging in a Stax transformer box? Or did I get screwed? Or am I an idiot? Like, what what happened to this thing? How did it go from working to getting home and then being dead? So I was looking at the bias on this unit, and it's currently 11 millivolts. Now, what I found, which was just purely by accident, this speaker impedance switch, when I brought it home, it was on 8 ohm minimum. And I don't know if I knocked it when I was moving it, because it's, you know, it's like just there, I can reach it. So I'm not sure what happened, if that was set to 4 ohm when I demoed it and I knocked it to 8. But when it's on the 8 ohm position, this thing runs crazy, crazy hot. And that is what it was set to when I brought it home. Now, the idle consumption at the moment, you know, is 56 watts at idle, which I'm like, cool. Then you got your bias here. But then I go and look at this, checking the bias adjustments and what it should be. So 11, that's supposed to be millivolts, by the way. 11 millivolts, speaker impedance switch, 8 ohm minimum. So it appears, unless this manual is wrong, I don't think it is. Well, that's wrong, so who knows. But it's not working correctly. So 8 ohm minimum normal. 8 ohm minimum 4 ohm is what it is set to currently. Now, if I power this thing down, I'll let that just discharge for a minute. Now, if you're wondering what that switch does, I went and looked in the service manual. So this is a switch here. What it does, by the looks of it, is it changes the transformer taps to a higher voltage. And that seems to back up what I saw, because the voltages have gone higher on the rails now. They've gone from 45 to 58 volts. So if I flip this, I'm not going to do this for long because it's not good for it, and fire it up again. So power consumption is rising quickly. Okay. We've already passed 20 millivolts, 21, 22, and I bet it's going to just keep climbing as it gets hotter and hotter. It's going to run away. 110, 111, 112, 113, 114, 26, still climbing, and we're turning it off. Okay. And these heat sinks are getting hot already. So that alone is telling me that that is not the right bias setting for this amp, because it should not be able to overheat itself by just switching that across. So someone's fucked with this amplifier, and as a result, it has killed itself. That is my conclusion on this so far. So I'm going to redo the bias on the 8 ohm minimum setting and see what it does, but obviously the amp's already damaged, so we can't. I'm just curious at this point, because at the moment it's sort of just a paperweight. So yeah, let's I'll do the bias and we'll come back. Okay, so it looks like we got the bias under control and hopefully saved it from more damage. So, you know, it's still on the high side, but that's because it's really cold where I am at the moment. I need to take it inside and do the proper calibration, but we just want to get under control at this point. So basically, on every channel, there is a connector here, which I'm plugged into at the moment. There's one there, you know, there's another one there, there's another one there. So they're the connectors for checking the bias. And then you've got these adjustment trim pots, one on every channel. Where's that one? They move around a little bit, but they're all the same still. So yeah, you just set the bias to 11 millivolts per channel, but it has to be done with it hot in a proper environment, with the cover on, take it off, adjust it, put it back on, and to get the proper stability. So yeah, the bias is good. It's running on that setting that would normally kill it, and it is not going nuclear now. So we're doing good there. So let me just show you the bottom of it. Okay, so we've removed some components. I've taken out all the power resistors that were burnt. I've disconnected the outputs, removed the emitter resistors, and there was another resistor that I took out over here. So this is all sort of just to get this unit out of circuit so I can test the rest of this amplifier and get it out of protection mode, which is all good. It's out of protection now. This is what was hanging me up because it was minus 48 volts going into the into the output still, which was triggering the protection circuit. So disconnecting this resistor off the B minus, which I'm assuming is for feedback, has resolved that. So that's disconnected. We're going to go through this later and make sure everything is out of circuit. So there's nothing left connected, which is going to be a job. So the question is, what are we going to do? Well, I can't fix this, I don't think. I can probably get new outputs, but I don't know if they're legit or not, and I'd have to wait a month to find out if they are legit. The emitter resistors, flat out can't get them. I would have to use something different, which I'm not a fan of. All this random stuff in here, like the burnt up resistors, which are apparently a bespoke Sony item, the transistors, all this stuff, I don't think I can get replacements for in a way that I would consider it like for like, it'll match whatever is in the other channel. So I'd probably have to do both of them to match them up. And I don't want to do that. So what are we going to do to salvage this amp? Well, we're going to try something a little crazy, and let me flip over and I'll explain. I know what all you are saying. Let's swap components from the working center channel to that channel, rebuild it, get it online again. I could do that and I could attempt it, but the risk of what could go wrong is ridiculous. If I miss one component in here that is not good anymore, and there's a lot of damage, and I move parts across, I could take out those parts, and then I've got 2 dead channels. If I end up with 2 dead channels, this amplifier is a paperweight at that point. I can't do much with it without 4 channels. Yeah. So the plan, and this is a crazy plan. Well, probably the craziest thing I've done so far. I've never worked on a multi-channel before. We are going to attempt to make the center channel think it is the front left channel. All of these channels are symmetrical from what I can read in all the schematics and looking at it visually and everything. They're just modular channels that are all the same. So I've identified 3 things that we need to do to make this happen. Well, in my head anyway. These are the audio inputs for each channel. So we have to swap the center with the front left first up, right? Takes care of the audio input. Then we have these relays. And I believe these relays, from what I can read, switch on or off the bias for each channel, which essentially brings them in and out. So we've got to make this relay switch on when that one switches on, blah. Okay? And the final part of this puzzle is the outputs have to be swapped also, which I've looked on the schematics, which should be fine. They all feed into this connector. So that output is there, that comes down. So they all go to different pins. And yeah, we've just got to swap them. And I found the connector, it's right there. And it's already labeled. So we have to repin the wires and swap the outputs of those 2 channels. In theory, that's all that needs to be done to make this channel work as that channel. Is this going to work? I don't know, but we're going to try. Funny side note, these are the 2 rear channels. that's normally front right, that's normally front left. So technically, it will be symmetrical after we do this, if it works. So we'll have two front, two rear, and they're going to be bridged together, so 200 and something watts per channel across these two pairs, and then this rear section will just be doing nothing, and we'll probably depopulate pretty much the entire area and get it out of circuit permanently, because I can't get parts for this. It's just not going to happen. So we're going to attempt this. I don't know what's going to happen, but let's find out. Okay, I sort of gave up filming in this area because it's too tight, basically. So yeah, all the wires run up. There's a connector here and a connector down there. You can see black on white, white on black now. That is the two channels that have been swapped. I have repinned this connector for the output. That is done as well. I don't believe it. This was a success. Believe it or not. All right, BTL mode is working. The two left, right, front channels are all working fine. So it's good to go. I don't believe it. I've redone the bias inside with plenty of heat, you know, just to climatize it properly, and everything calibrated perfectly. The carnage was significant. The emitter resistor was blown in half almost. So that was a good one. These outputs are shorted and dead. These are like thick things. Surprised, like the quality is just outstanding in this amplifier. And this is not the amplifier's fault. This is someone who didn't do things correctly that killed this unit. Yeah, some fused resistors that have just open circuit, and there's some other ones that are shorted, and a Nichicon Gold that's bulging a little bit, I noticed as well. So I don't know, a bit hard to see on camera. Yeah, it might need a recap at some point, because some of these caps that I pulled out just to have a look are getting a bit low in their values compared to what they're supposed to be. So probably do that in the future. Yeah, so these relays I thought I'd have to mess with, and I don't. Turns out these relays are for the standby circuit when this is connected to a preamp, and I guess it turns it to a lower bias in standby or something. And yeah, it is related to the bias, but not in the way I thought it is. It runs all the channels at full power all the time, no matter what mode you're running it in. So I was testing the relays, trying to get them to turn on, and they just don't. They because I don't have the link to put it into standby mode. So yeah, I've depopulated most of this channel, left a few things in, not for any particular reason. It's just I just sort of stopped there. The outputs are gone. I've sort of cleaned everything up. In regards to removing the channel from everything, I basically just disconnected everything I could find on the B plus and on the B minus rails, and until I wasn't seeing any voltage anywhere in the circuit, and everything is good now. So yeah, nothing to really worry about there either. We're done. Bias is done. It's calibrated. Looks nice and symmetrical. I'm happy to just start using this and enjoying it. We'll do a video on this amp a little bit later, and I'll show you around its amazing features. Like, this thing it's just a monster. It's 24 kilos, and I just don't give Sony enough credit for putting out hardware like this. I've never really messed around with Sony amplifiers for whatever reason, but this thing is just amazing. Like, look at the copper chassis and this crazy stuff. It's just, I love it. I love it. I love it. I love it. I want another one now. Yeah, well, that's it for this video, and we will continue on to the next one. Hope you enjoyed the video. Until next time.